So, hi everyone, let's move forward. And moving forward, today we are going to discuss about the very important thing, that is the drawback of drawback of Rutherford's model of atom. Rutherford's model. So in last class we have discussed about the Rutherford's model, as well as we have learned that what was the that experiment he did, which is called as alpha particle scattering experiment, and we came to the conclusion that most of the space in an atom is empty. After that, Rutherford related his model with the solar system model, and he told exactly like in solar system we have the sun in the center, we have the nucleus on the center, and like planet, the electrons keeps on revolving. But this was the Rutherford's model given. But do you know what happened? There was one scientist whose name is Maxwell. So Maxwell at that time he was doing an experiment based on electromagnetic radiation. He was working on electromagnetic radiation, and what he observed that whenever there is a charged particle, any charged particle, and that charged particle is under the movement, is under the motion, right? Whenever a charged particle is moving under the influence of any attractive force, there is a charged particle, and under the influence of any attractive force, there will be an attractive force. What will happen? The charged particle will start radiating energy. It will start radiating energy. Radiating matlab emitting, losing energy, and this energy will be lost in form of electromagnetic radiation, right? So same thing, Rutherford has given some idea based on this one. So according to Rutherford model, I hope you all remember, there was a nucleus in the center, and there was a negatively charged particle which we called it as electron. This was my electron, and Rutherford told that this electron keeps on revolving around the nucleus in its circular path like this. Ignore about my drawing skills. My drawing skills are worst. Yeah, think this as a perfect circle. So electron keeps on revolving around its own orbit, just like the in solar system we have the planet. But this Maxwell idea changed everything. Right now, what happens in this atom? This is my nucleus. This was my nucleus, and the nucleus contains a positive charge, and this is my electron, which contains a negative charge. Now, what is the force between two oppositely charged particles? Between two oppositely charged particles, there will be a force of attraction, right? Electron and nucleus, they will attract each other, and this is called as force of attraction. But the idea changed here completely when this Maxwell gave the theory. So according to Maxwell theory, if this is the nucleus and here is my electron, and this electron is revolving around the nucleus, as electron is negatively charged particles, and the force between electron and my nucleus is the force of attraction. Gradually, as electron will start to move at every point, at each point it will start to radiate the energy in form of electromagnetic radiation. It will start losing the energy, and I hope you can understand this thing, that if something is radiating the energy, for example, let's say there are two person and they are playing tug of war, right? So let me show my amazing drawing skills to you. Let's say this is a person A and this is the person B. Okay, person B is quite sad. They are playing tug of war, and this is the middle point, right? So what they are doing, both are trying to pull the rope towards themselves. Now what will happen? Let's say, let's imagine a condition. In this condition, this person B, this person B start to lose energy because this person A is trying to pull, and gradually B is getting tired, and as he will get tired, he will start losing energy at each and every point. So जैसे ही B will start losing energy, B will come more close and close towards A, right? First it will come here, then it will go here, then here, here. Ultimately he is about to fall on A, right? Same thing will happen in this case. At every point the electron will start radiate energy. यहाँ पे at every point electron is radiating energy, because this is a moving particle. Whenever the moving charged particle is under the influence of any attractive force, it will radiate the energy. This is what given by Maxwell. Now, as this electron is losing energy or radiating energy, gradually there will come a point at which this electron will fall on the nucleus. तो यहाँ पे क्या होगा at the end electron will fall on the nucleus, right? So when this electron will fall on the nucleus, at that time, what will happen when the what to say? Sorry, when this negatively charged particle electron will fall on the nucleus, at that point, do you know what will happen? Atoms collapse. Atom collapse. Atoms cannot exist. It will blast. It will radiate the energy. Atom cannot stay, right? It cannot exist. It will break down into small pieces. Now, do you know one amazing thing? This was the assumption or this was the conclusion that everyone predicted with the help of Maxwell theory. And yes, this was the drawback of Rutherford's model due to which the model got failed. But practically, this thing, atom collapsing, will not take place, will not happen in reality. Reality में this thing never works. Reality में never ever the electron will fall on the nucleus and the atom will blast. It's not so easy that you can break a atom. It's very difficult. So this was the main drawback. This was the main point due to which this Rutherford model got failed. ठीक है? And he did some calculation, and according to this calculation, uh, it shows that this electron takes somewhere around 10 to the power minus 8 seconds to fall on the nucleus, according to this calculation of Rutherford. But the reality is this will never take place, and due to which this Rutherford model got failed. It does not exist. So Rutherford, the main drawback of Rutherford क्या था? The main drawback was Rutherford was, let's note this point, Rutherford was unable to was unable to explain the stability to explain the stability of an atom, because whenever the electron will fall on the nucleus, the atom will not be stable at all. Atom will become highly unstable and it will collapse, right? So with this one, there came one more scientist into the picture. The next scientist was Bohr, Neil Bohr. I hope you all have heard about this person in your lower grade, in your 9th, 10th grade. Somewhere you might have learned about the Bohr's model of atom. And in that Bohr's model of atom, you have the brief idea about the cells, right? Bohr talked about the cells, and in 9th, 10th grade, you call the cells as KLMN cells. And you have learned about the writing electronic configuration. You used to write 288 in that form, right? So yes, that was the Bohr's theory. But here we are going to learn about the Bohr's theory in very much detail, right? So when this Bohr's model came into the picture, there was two main idea. The two main idea came into the picture or came into the mind. The very first idea was about the dual behavior, the dual nature, I can say, the dual nature of electromagnetic radiation. That electromagnetic radiation, it has dual nature. What is the dual nature? Dual nature का मतलब होता है, it was showing the particle like properties as well as wave like nature. Yes, this one EMR waves, the electromagnetic radiation, it has two types of nature. एक, sometimes it behaves as particle, sometimes it was behaving as what to say, wave nature, right? So as it was having dual nature, so something got changed, and what's that? We are going to learn in more detail about this one. Along with this, there is one more idea, that is our atomic spectra. Atomic spectra is also one of the important thing. Spectra matlab splitting of light. So whenever I talk about the white light splits into the seven bands of color. You might have heard about the seven bands of color in physics, that is uh, VIBGYOR, with GOR you used to say, right? So there are seven different colors or the rainbow colors. And if I'm not wrong, in class 7 8 you have learned something about Newton disk. where you take a white color paper, you divide it into 7 equal pieces, and then you paint with different colors, right? This V, I, B, G, Y, O, and one more here is R, right? And then when you spin it very fastly, you will see that all this color mixed together and you will see the white color. Now, this how this atomic spectra and all these two things led to the new this led to the what to say formation of the new model, that was Bohr's model, right? So before we go towards the Bohr's model, let's have little bit focus on this two important thing, that is dual nature and atomic spectra. So let's get started with the next very important concept, that is the nature of light. Now we are going to talk about the nature of light. Nature of light and electromagnetic radiation. How it is related to the EMR waves. How and what is the use of EMR in this concept. So earlier there was the very famous scientist of physics. I hope you all know this person named Newton. Newton Baba, we used to say in college, right? So what this Babaji told, this Babaji told us that light is actually made up of particles. According to Newton, जो light होता है, light is made up of particles, and light is made up of small particles, and this small particles we explain this particle nature. Newton explained with the help of two amazing thing, that is reflection. I hope you have heard about reflection of light, and one more refraction of light, sorry, refraction of light. So this two what to say experiment proves that the light has the particle nature, but light was showing some other behavior as well. What are those other behavior? I hope you might have heard about a term which is called as what to say, here I'll write, it is called as interference. Interference and diffraction. I hope everyone might have heard about these two terms in light chapter. In physics, you will learn about this thing. You might have learned about this thing in physics specially. So light shows the interference as well as diffraction. But why it is showing this thing? Newton was unable to explain this thing. Newton has no idea, no clue that why the light was showing interference, why it was showing diffraction. Reason is that to prove this thing, light should behave as a wave. Light को wave जैसा काम करना पड़ेगा. If light will not work as a wave, you cannot explain the interference concept. You cannot explain the diffraction concept. But according to Newton, light was a particle, and if it is a particle, light will have reflection and refraction. These are the only two things, right? So we'll come about this thing. Iske pehle, what we'll talk here, let's see what is EMR, what is electromagnetic radiation. First, let's learn about this radiation part, and then we'll come about this dual nature of light and all, right? So let's go with this next thing, that is electromagnetic radiation. I'll write in short form EMR. Electromagnetic radiation bolte hain, or sometimes we can also call it as electromagnetic waves. Both are same thing. In chemistry we say that electromagnetic radiation or electromagnetic waves. So EMR waves, iska idea was given by Sir James Maxwell, right? His name was James Maxwell. So I don't remember the year exactly. It was late 18th century. In late 18th century, Maxwell, what he proposed that the light and other form of radiation of light, एक तो light and that other form, they propagate through the space in a form of waves. Yes, so you might have learned about the sunlight, right? Sun comes from the space. How it comes? Because we all know that outside Earth in space we have vacuum. There is no medium. Still light is traveling. So similarly, what he told, Maxwell explained that जो light है, the light and other form of radiation, and other form of radiation, they travel in form of waves. वो waves कैसे travel करते हैं? For example, I hope you might have seen this thing. when you throw a stone in a river or in a water, right? I'll try to show my again amazing drawing skills. Let's say you threw the stone here, you will see this type of waves coming out, right? First wave, then second wave, then third wave, like this. Slowly you'll see the waves which are coming out. ऐसे करके you'll see the continuous wave. It will keep on coming, right? So this first wave will form the second. Within that, one more new wave will originate. Then one more, then one more. Like this, so many waves will keep on coming out together, right? So ये जो wave होता है, what this Maxwell told, he told that this wave actually this have electric and magnetic. This have electric and magnetic field field associated with them. And this wave, which has the electric field component as well as magnetic field component, this type of waves are known as electromagnetic waves bolo ya electromagnetic radiation bolo, both are same thing. I hope this is clear. What is electromagnetic radiation? Electromagnetic radiation or electromagnetic waves is a form of light or any radiation which has two major components. One is my electric field component, one is my magnetic field component. अगर ये दोनों if these two components are associated with one single wave, those type of waves are called as electromagnetic waves or electromagnetic radiation. I hope this point makes sense, right? Now, I hope you have learned something about the waves also. You know the basic thing about waves. Now, let's talk about the wave in brief. So, let me try to draw a wave, something like this. Let's say this is the line of propagation. This is a wave. Wave travels like this. Okay? Now, this is the mean point. We take it as 0. Now, whenever you talk about a wave, the wave has two things. One, point of maximum. This is point of maxima. This is maximum point. And there will be a minimum point. Point of minima, you can say. This maximum point is called as crest. इसको हम बोलते हैं crest. 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 ठीक है? And the minimum point is called as trough. 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 ठीक है? The point at which the wave can go to the maximum height, that maximum height is called as crest, and the minimum height is called as trough. So there are two types of point. One is crest, maximum point, trough, minimum point, right? Now the wave जो होता है ना, the wave is considered to be it is the disturbance. How the wave is originated, just now we learn here. देखो, there was a water which was very calm. If it was very calm, can you see any waves? No. What we did, we threw a stone. यहाँ पे हमने stone फेंका, right? As soon as I threw this stone, what I did, I disturbed the entire river, right? I disturbed that what to say, calm thing. जैसे ही I disturb, what happened? Why there was wave? Because of the vibration caused, right? Same thing. In the similar way, the wave जो होता है ना, the wave is created because of the disturbance. Whenever there is any disturbance which is causing, so due to this disturbance, there will be vibration. And this vibration क्या होगा? It will travel outwards as a continuous sequence. ये vibrate होके it will come on, it will keep on moving outside, just like wave I explained. You threw a stone, you'll get the first wave. जैसे first wave will go, you'll get another new wave, then new wave, then new. It will start on emerging new, and this is emerging because of the vibration caused, the disturbance caused, and it will keep on moving, right? So when, and you have never seen a wave like this, a circle. Wave is not a circle. It will go like this, right? It will have this type of movement, sometime up, sometime down, in this way. If you see the wave, again in this drawing I'm not able to draw nicely because my drawing skills are very worst, but yeah, you can do this experiment at your home. You can take a bucket full of water, and after some time you can throw a stone on it. If you throw a stone, you will see this type of waves originating from there, right? Okay, great. Now let's see, let's talk about few points of this wave. There are few important things about this wave that we should know. The very first thing, we have something called as wavelength. Something called as wavelength. When wavelength is denoted by the symbol is known as lambda. This is called as lambda. LAMD. LAMBDA. Lambda. ठीक है? Now, what is the wavelength? Wavelength, as the name says, the length of a wave, right? The length of one wave. एक wave का, if I measure the length, that is called as the wavelength. Now, how to measure the wavelength? You can either take the distance between two maxima. This is one maxima, and this is another maxima. You can take the distance between these two maxima, that is your lambda, or between two minima, या फिर two minima के बीच में ले लो, that is your wavelength. ठीक है? The distance between two consecutive crest or two consecutive trough is known as the wavelength. I hope this is clear. It is the distance between two adjacent crest or trough. The distance between two adjacent crest or tuft is called as wavelength, and wavelength is denoted by this Greek symbol which is called as lambda. अब एक चीज याद रखना, whenever we in paper and everywhere you'll see na lambda has a unit. Generally we express the wavelength in terms of angstrom. We write angstrom like this. This is called as angstrom. 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 This is the unit. Okay, unit to measure the length. So what is angstrom basically? So I say that 1 angstrom is nothing but it is equal to 10 to the power minus 10 meter. 10 to the power minus 10 meter is called as 1 angstrom. ठीक है, इसको याद रखना. Or if I want to express this thing in centimeter, I hope you know that 1 meter is equal to 100 centimeter. So I can replace this by 10 to the power minus 8 meter. Centimeter. This is how I can express the wavelength. Now, एक चीज याद रखना, we are talking about the length. In exam, it's not always necessary they will give you the length in form of angstrom. They may use any unit. They may use meter, centimeter, picometer, nanometer, femtometer, anything. Remember one thing: whenever you will try to solve any numerical, first of all you will make everything into the same unit. Unit must be same before doing the calculation. If units are not same, better you will get the answer wrong. You will be thinking, yes, I put the correct formula, I put every units, my calculation was correct, everything was correct, still I lose marks, still I got -1 negative marks. Why? Because better today unit convert nahi kiya tha. Always unit you have to keep in same unit, right? It can be given in anything. So just say I can say 1 angstrom is nothing. It is equal to 10 to the power minus 10 meter, which is also equal to 10 to the power minus 8 centimeter, which we have already written. Sometimes they can give you in micro. Mu is called as micrometer. If they are giving you in micrometer, 1 micrometer is 10 to the power minus 6 meter. Right? Sometimes I can give you 1 millimicron. Millimicron matlab mu. 1 millimicron is 10 to the power minus 9 meter. Similarly, you might have heard about nanometer. So 1 nanometer is equal to 10 to the power minus 9 meter. हमने पढ़ा होगा 1 picometer. Picometer is 10 to the power minus 12 meter. Femtometer we generally don't use, but femto is 10 to the power minus 12. So these are the few unit conversion. This you have to keep in mind. Okay, unit conversion इसको याद रखना. I hope wavelength is clear. What is a wavelength? Wavelength is the distance between two adjacent crest or two adjacent trough. Right? This is called as the length of a wave. Now moving forward, let's see about the next part, that is frequency. What is a frequency? Frequency is represented by nu. Nu, how you can write? You can just write a V, simple sa V, and make it cursive. Just turn it. This is called as nu. N-U-E. Nu. This is how you pronounce it. Okay? This is the way of pronunciation, right? We write the symbol as nu. What is the frequency? Frequency matlab, see, let's understand the basic thing in English. In English, what we say frequency, how frequent something is, how many times something is coming, right? That is called as frequency. Similarly, in case of EMR wave, what is the frequency? It is the number of waves which passes through a given point. There will be a given point. Through that point, how many waves passes through it in 1 second? 1 second में how many waves are passing? That is my frequency, right? So if I want to write the definition, I can say it is the number of waves. It is the number of waves that passes through a point, that passes through a point in 1 second. Point in 1 second is called as frequency, right? Frequency is denoted by a Greek symbol, that is nu. And what is the SI unit of frequency? SI unit of frequency is hertz. Hertz. Okay? There is the SI unit of frequency. And we say that 1 hertz जो होता है ना, 1 hertz is equal to 1 cycle per second. 1 cycle per second. So one complete cycle in 1 second is equal to 1 hertz. I hope this is clear. Correct? Let's move forward towards the next part. Third important thing is velocity. Velocity is denoted by symbol c. Right? Velocity का मतलब क्या होता है? Velocity का मतलब होता है it is the distance traveled by a wave. एक wave how far it can travel in 1 second. In 1 second, one wave how much distance it can cover, that is my velocity. So I can say velocity is nothing. It is the distance traveled by a wave in 1 second. By a wave in 1 second. In 1 second, how far it can travel, that is called as velocity. And velocity is always represented in the unit of meter per second. Okay, okay, great. Similarly, we have one more thing that we rarely use in chemistry, that is amplitude. That is amplitude denoted by small a. What is amplitude? Amplitude is actually the height. This one. Let's see the diagram here. Where was the diagram? This height of maxima या फिर this height of minima. चाहे you find for maxima या minima, मतलब the height of crest or the height of trough, that is called as amplitude. ठीक है? Amplitude क्या होता है? It is the height of crest or depth of trough. Height of crest or depth of trough is of a wave is called as amplitude, right? And basically amplitude क्या determine करता है? Amplitude actually determines the intensity. Sometimes for example in television, yes, best example, in television you have seen that we can increase the color, I can increase the brightness, I can increase the what to say, color saturations and all. जो intensity or brightness, it depends upon the amplitude. Yes, basically in TV when you click a button on remote, the screen gets more brighter, matlab you are actually changing the amplitude of the wave, because from television the waves are coming out, तुम बस उसका amplitude change कर देते हो. That is what uh, the amplitude is. Correct? And last one more point, fifth one, last one, that is your wave number. Wave number. Wave number is denoted by nu bar. Just write nu, give it a bar. This is called as nu bar. Okay? What is wave number? Wave number is the inverse of wavelength. Okay? It is the number of wavelength per centimeter. The number of wavelength per centimeter is called as wave number. या फिर in simple word I can say that wave number nu bar is equal to 1 by wavelength. Inverse of wavelength is called as wave number. ठीक है? And this is usually expressed in terms of सेंटीमीटर इनवर्स. वेवलेंथ इज सेंटीमीटर, सो इसका यूनिट क्या आ जाएगा? इसका यूनिट हो जाएगा सेंटीमीटर इनवर्स. या फिर इफ आई एम यूजिंग वेवलेंथ इन मीटर, इट विल बी मीटर इनवर्स. नैनोमीटर इनवर्स. पिकोमीटर इनवर्स, राइट? जो भी यूनिट रहेगा वेवलेंथ का, यू विल जस्ट मेक इट एज अ इनवर्स. सिंपल सा थिंग. I hope these 5 points about the waves are clear. So wave has 5 unique characters. सबसे पहले we study about wave. The distance between the maxima and minima is called as the wavelength. इसको हम wavelength बोलते हैं. This distance, the height of trough or the height of crust is called as amplitude. Now, the number of waves passing through a point, a point, say how many waves will pass. What do you call those things? We call those things as a frequency. Frequency is the number of wave that passes through a point in 1 second. एक second में how many waves are getting passed. उसके बाद we studied about velocity. Velocity क्या होता है? It is the distance traveled by a wave in 1 second. In 1 second, how far your EMR wave can go, that is called as the velocity. And last part we learned, that is the wave number. Wave number is the inverse of wavelength. Now, there is a very important relation that you have to keep in mind. So last one is relation between wavelength, wave number, frequency and velocity. Frequency and velocity. Velocity is c, right? What is the relation between them? So there is a very simple relation. We say that velocity c is equal to lambda into mu frequency. Or if I arrange it nicely, I can say that nu is equal to c upon lambda. The very important relation you have to keep in mind. There will be so many numericals which will be direct from this one. And एक और बात याद रखो, 1 by lambda को हम क्या बोल सकते हैं? I can say 1 by lambda is mu bar, wave number. So I can say mu is equal to c into mu bar. I can write this thing like this also. ठीक है, जिसमें दिस इज द मोस्ट इंपॉर्टेंट फॉर्मूला, इसको याद रखना. डायरेक्टली दे मे गिव यू द क्वेश्चन बेस्ड ऑन दिस थिंग. डायरेक्ट न्यूमेरिकल्स विल बी देयर. ठीक है, numericals and all will be doing in the next class, and then we'll see the characteristics of EMR wave, how the wave travel. We learn that it has two components, one is electric field component, one is magnetic field component. How the wave travels, nature and EMR spectrum will go in the next class. So for today, this much. We'll meet on the next class. Till then, thank you so much.